All right, let's get started. I think we have a good group. People are joining us as we speak. Hello, everyone. Good morning, good afternoon, good evening from wherever you're joining us. I'm very happy to have you here for our last user call for 2023, sorry. My name is Dalia and I work as a community manager here at Kong. The topic for today is Kong Gateway 3.5. What are the updates there? And then Wasm-X. So we have Veena and Hisham with us today. I will let them introduce themselves. Let's take all of the questions at the end. You will see a Q&A button on the bottom, so please insert all of your questions there and we will answer them at the end. This webinar is recorded, so you will find it later on our YouTube channel later today. Cool. All right, Veena, take it from here, please.
Thanks, Dalia. Hello, everyone. Welcome to Kong Gateway 3.5 webinar. I'm glad you're all here and excited to present this. My name is Veena. I'm a product manager on the Gateway team. We had some cool stuff going into Kong Gateway 3.5. We'll get into the details. Let me just see if Hisham is able to introduce himself. He had some technical difficulty, so hopefully he can hear us.
Hi, yes, I can hear you. Yes. And, happy to be here. I'm Hisham, work with product and engineering in the Wasm-X team, and I'll talk about the WebAssembly bits of Kong Gateway 3.5 later after Veena. Take it away, Veena.
All right, thank you. So the 3.5 release Kong Gateway, which is now referred to as Kong Enterprise, Kong Gateway Enterprise, I would categorize two big buckets of capabilities that went into it. One that is available in both open source as well as enterprise versions, and another category of capabilities that are targeted for our enterprise customers. Improvements to our plugins, new features in our plugins, etc. So big bucket of observability improvements and enterprise plugin and use cases. So let's. So at a thematic level, just kind of put them in three themes. On the enhanced, one is the enhanced observability. 3.5 had new capabilities as based on feedback from our users, customers, where they're running into issues and they don't have a quick and easy way to debug Kong, understand what's going on, where Kong is spending time. So we introduced this capability to debug requests in what Kong sees, and on demand capture the timing information as that request makes its way through Kong and different phases within Kong, and narrow down the issues. It could be whether it's a network call outside of Kong that's taking the time, or if it's the upstream API that's kind of slow. So you kind of get this debugging information or a trace of a different time that Kong is seeing as the request throughout the request lifecycle. So that capability is turned on. We'll get into the details in the slides in later slides, but just summarizing it here. As part of that same theme, we also introduced something called request IDs, which is a unique identifier. So every request that hits Kong gets assigned a unique identifier. There was correlation plugin before, but this is coming out of the box from Kong, without having to do any setup from the user's perspective. So every request gets assigned a request ID, and that is propagated into logs and traces, and you're able to correlate all of that information together. So a lot of customers have asked for capabilities how they can trace, tie the traces and the logs together to understand what's going on. So this enables that as well. And in another improvement we had generally in the space is improving our P99 latency, right? So we have various deployment modes for Kong. One of them in the hybrid mode, what was happening was we did not have, as Kong is processing your traffic, the data, it had to, the other part of it, we did not have clear separation, wherein the control plane is pushing some configuration updates as and when you make changes. You may be adding plugins, or you may be onboarding new APIs. So all those configuration changes, when they were pushed down from control plane, because of lack of separation, wherein the workers had to spend time taking time away from processing traffic to process the configuration, the P99 latency was taking a hit. So what 3.5 has is something called a dedicated configuration processor. So wherein you're dedicating one of the processes to mainly handle these configuration updates, while the others are doing your traffic handling, right? So this improves the latency, and there is a slight memory footprint, but the advantage is more in terms of improved latency. So I think this feature is on. It can be turned off like any of the features in this list. On the second category is the security and compliance. So this is targeting our enterprise plugins, improvements to our enterprise use cases. If you are in writing financial grade APIs or doing something with open banking, there are requirements that you need to adhere to, right? So one of the requirements of open banking or financial API is that around token security, ensuring that tokens are used by the end users or the consumers to whom that token was issued. So this kind of is a requirement on the open banking side. So we support that in our OIDC plugin today. There are two ways to support this ask, and we have implemented one in 3.5, which is using the MTLS. I'll go into the details in the next slide. Another feature is the Azure Vault support. In the previous releases of Kong Gateway, we released support for secrets management using AWS Secrets Manager, HashiCorp Vault, GCP, etc. And now in 3.5, we have support for Azure as well. So this kind of checks off all the major players in the secrets management space, and Kong integrates with all of them, right? So this is the first API management solution to do that. And we had another go into, with the PNA, private network access, which is another handshake in the course pre-flight. So how the public websites access private servers and they have to ask for permission. So Chrome is rolling this out, and we're happy to roll that out in Kong as well to enable those changes and be in line with this specification as well. And lastly, in the Boost developer efficiency list, we have support for AssemblyScript in Wasm, right? So previously, Wasm was released as beta, and it supported Go and Rust languages. And in 3.5, we added AssemblyScript as well, and Hisham will talk in detail about that. All right, the first one, which was the debug information, right? So one of the features that commonly was seen across both open source and enterprise customers was that a way to debug Kong and to collect some traces. So what this capability brings is, using a header, you can trigger a request to either a route or a service that having the issue, and what it will do is it will collect granular timing information of all the different phases and give that result back in a response header. So admins, gateway admins, it is locked down. Not everybody can trigger this, right? So there is a token that each Kong instance is going to have. It's only the admins can trigger this request, this debug request. And this basically helps you understand, what's going on, where Kong is spending time, identify issues, kind of like live debugging, and troubleshoot any of the latency issues, and kind of minimize the downtime for your Kong. So this has been a big ask from our customers, just to show how the request and the response looks like. So you send a request with a couple of different headers. The token is something that the admins can get from Kong itself. It's in a file, and the output of that is sent back in a response header. So you can see that the different time at different levels that are collected, and it could be DNS issue, or it could be that your upstream is slow, or any other network call. and you can capture details in this response and as you try to troubleshoot. All right, and I mentioned also the request identifier that is added to as part of this. You will see the request identifier as well in the previous trace. The unique identifier gets attached to each request, and that's propagated to logs and other plugins that emit different signals. So you can easily debug and correlate traces and logs, right? So this is another improvement. And this is available, both of these are available in the OSS as well. All right. In the security and compliance, we added support for something called sender constrained access tokens. So what is this, right? So if you are developing financial grade APIs or open banking, adhering to open banking standards, there is a requirement that your tokens need to be locked down. So only the users to whom that token was issued are able to use that, right? So this kind of mitigates the risks with leaked and stolen tokens. So they cannot replay those tokens back, and it cannot be used again because Kong is now going to enforce that check. So how does it do that, right? So I have a diagram. We can just take a look at that. So as there is a bit of setup because we are using MTLS to handle this. So the client certificates that are issued to your clients, right? They use that client certificate to establish an MTLS connection to your token issuer, right? So your authorization server or your IDP. So once the connection is established and the client requests for a token, what the authorization server does is, as it issues the token, it will imprint or put a thumbprint of that token inside the token, right? So all tokens issued would have this certificate thumbprint, and when client presents the token to Kong, along with, we also need client to establish an MTLS connection using the same client certificate. What Kong does is Kong will check that, the token, the thumbprint of the certificate inside the token matches what's coming in the connection, right? So if there is a match, that's when it'll proxy the request to the backend. Otherwise, it'll reject it. So this ensures that the tokens are not reused or misused. If the tokens get leaked or stolen, they cannot be used by somebody else, some other user or some other client, right? So this is a requirement of open banking and FAPI standards, and Kong is checking off this box as well. So just to go back on that, again, another layer of security, because you are requiring the presenter of the token to prove that they actually are the person to whom it was issued. And, you're adding this secure, mitigating the risk of leaked and stolen tokens. Right. The last feature in this security and compliance, again, is the support for Azure Vault. So previously, when we rolled out the secrets management, kind of helped centralize your secrets, use industry standards, wherein, such as, if you're using, depending on where you might be, AWS Secrets Manager, GCP, or HashiCorp Vault. Now we roll out support for Azure as well in 3.5. So you're able to use Azure Key Vault as a secrets manager, and Kong will integrate with that as well. So this makes it, Kong supports all the major players here, centralized, all the benefits you get with centralized secret management and any of the security compliance that you need to adhere to. This is an enterprise only feature, right? So that's, and I talked about the coarse private network access. Again, it is a coarse handshake between, it's the handshake that happens in pre-flight. So now Kong can, the coarse headers will be injected, and you can turn that capability on in our course plugin as well. So that is in sync with what has been rolled out by Chrome and others, if not already rolled out. So we are in timed it well, so we can support that as well for our customers. That's all the updates I had for 3.5. Any questions? I think we'll take that in the end. I'll hand it off to Hisham, who's going to talk about the Wasm assembly script.
Hey, thanks, Veena. So I am having some technical difficulties with sharing my screen, and I had prepared some slides and also a demo, but I think if Veena or Dalia, if any of you can share my slides, then I can give the slide part of the presentation. So I've sent you on Slack the link to my slides.
Veena, do you mind sharing? Just a sec.
Yeah, just give me a minute so I can just down.
And then since I cannot give you a live code demo, I will come up with something else at the end.
All right.
Stay tuned for a surprise.
Let me just share my screen again. All right.
All right, thank you. So so since we're going to be talking about WebAssembly, which is an upcoming standard and for backend extensibility, really, like it's already a pre-established piece of tech in the front end. So I figured like and this is still a beta feature in Kong Gateway. I figured I would start with a quick recap of what WebAssembly is and how it fits in the Kong Gateway, and then at the end, like I was going to focus most of the new stuff for 3.5 in the live demo section, but I will present it in a different way. But let's start with the recap to make sure we're all on the same page to understand what's going on. Yeah, thank you. So I'm going to be talking about those three pieces. Like first explaining like what the Wasm tech stack is all about, like what are WebAssembly to put us on the same page, and what is Wasm-X, which is like the tech that we're developing that powers WebAssembly in Kong. Then I'm going to be talking about Wasm filters in Kong Gateway. So that how does that fit into the world of route services and what we call the Kong entities. And and finally, I'm gonna do the little surprise there. So next slide, please. So WebAssembly in one sentence could be summarized as an industry standard spec for sandbox language runtimes. Right. So next slide, please. You can look at it as something that started in the browser and is an alternative to JavaScript, which has a few important characteristics. It's an open standard. It's not a VM for a particular language. It supports multiple languages as a single binary code format, and which defines the format for the binary files and the virtual machine with their behavior. Right. So multiple languages are supported, and there are several implementations. Next slide, please. Yeah, so in the context of Kong and the gateway, right? Like just like Wasm is an alternative to JavaScript in the browser, for us, it is an alternative to pretty much like the monopoly of Lua, because like Lua is the only like first-class citizen really in the gateway. We have the Go PDK, we have the other PDKs, but those runs as plugin servers, which are like a sidecar process to the gateway, which have more like operational challenges and so on and so forth. So bringing a WebAssembly VM like into the gateway, running in the same process at the same first-class level, will give us a bunch of benefits, such as improved performance and a tighter integration, plus some things that only WebAssembly gives us that the Lua VM doesn't, such as improved sandboxing capabilities, and also it obviates for us the need to implement multiple PDKs for different languages, right? So next slide, please. Yeah, so in short, like those pieces for WebAssembly are the binary format for compiled bytecode files, which are .wasm files. You can think of them sort of like Java class files, except that they bundle like all of your dependencies as well, which means also easier like deployment for operations. And the multi-language virtual machine, there are several, like Wasm-Time, V8, Wasmer, and we in our default builds, we integrate Wasm-Time. Our backend tech for WasmX supports multiple types of virtual machines. You can think of the multi-language virtual machine sort of like the .NET virtual machine, which also supports multiple languages, right? And the third part is the API, right? So the APIs for embedding VMs into host app means that you get like a C library, like wasm.h or something, that will allow us to take this virtual machine and embed it inside a host application. And the host application for us is, next slide, please. Yeah, it's WasmX, which is our Nginx module that implements a Wasm host. And then it exposes this for the programmer, a proxy Wasm API. So let's move into that. The next slide. Yeah. So what this enables us is that with the WasmX integrated into the Nginx process that runs Kong, just like OpenResty allows us to run the Luajit VM and run all those little blue boxes, which are the Lua code, it allows us to run those purple boxes, which are the Wasm filters, right? So, and those Wasm filters are developed by end users who will extend the application using the proxy Wasm API, which I'm going to explain next. So, next slide. Yeah. So proxy Wasm filters are Wasm modules, like those .wasm files, which are compiled from source code in your favorite language that implements the proxy Wasm SDK, right? So they implement essentially event handlers for request lifecycle. So they sit through the request lifecycle and they implement essentially callbacks, like event handlers for those various parts of the life cycle, like getting HTTP headers, processing the HTTP body from the request, and then the response, logging, and so on and so forth. But they run in the Wasm sandbox environment, like unlike the Lua plugins, which can pretty much do anything with the Lua state. This is a lot more restrained and well-defined in terms of scope of what is allowed. Next slide. So yeah. So proxy Wasm is not something that we came up with, like WasmX is our implementation of proxy Wasm, but proxy Wasm itself is a language-independent binary interface, right? It exposes the entry points for various SDKs, which are also developed by third parties for providing programmers with those APIs. So there are third-party SDKs for Rust, for Go, for C++, for AssemblyScript, and it's an evolving specification, which is gateway independent, and it's something that we are adding more and more on each day for giving those binary entry points so that the SDKs can run. Next slide, please. So for us, once we implement this API, we get all those language SDKs, which is super interesting because you can, like, we have Kong Gateway, which is based on Nginx, but we also have Kong Mesh, which is based on Envoy and already supports proxy Wasm. So it's really interesting to be supporting and helping to evolve this industry standard that will allow us to provide like reusable extensibility in multiple languages. So so the key ideas here is that we at the Kong Gateway, we implement this binary interface, which allows for those third-party SDKs to be used in various languages, right? And with that, you can compile those Wasm files, which gives you the filters, right? So all of this was conceptually released first on Kong Gateway 3.4. And we are continuing to make progress on this in terms of the coverage of the SDK and the amount of supported functions, and also some quality of life features and verification of support for multiple languages, as Vina has already touched on. So next slide. Yeah. So how that fits in the gateway is through the idea of filters, which we talked about, and also like the concept of filter chains, which are the new Kong entity that are your interface for integrating filters to your routes and services. Next slide. Yeah. So this slide, like if you are very eagle-eyed, you might already see a little difference between Kong 3.4 and 3.5, and which was like a DX, a developer experience, like, or UX, sort of quality of life improvement that we're going to see later. But essentially, the idea is that like this is a piece of declarative config that you must be well used to. So essentially, like filter chains are just Kong entity that associates Wasm filters, like a list of Wasm filters to routes and services, right? And they can list multiple filters written in different languages, each one of them with their own configurations. And as we go, like both if you define a chain to a service and to a route, like both of them get executed in order, right? The filters within each chain are defined on the chain, so you can define the order of your pipeline. This is very different from how Lua plugins work, in which all of them has like their own fixed priority. And the chains run after Lua plugins on each phase. So you get like access Lua plugins, then access all of the filter chains, and then like header filter, body filter, logging, and so forth. All right. So yeah. So now I was going to jump into a live demo to show them running in action, but instead, what I'm gonna do is something a little different. I'm gonna send Vina a link from our GitHub repo and ask her to please show us. I can even put it in our. I could even put it in our chat here. So yeah. So with that, we can see like how I'm gonna show you very quickly how that works for developing a filter and getting that running. Like essentially the logic on the filter, it's all on main Go. But what I was going to show you here running was going to be if you get in the if you go into the test folder. Yeah, so the test folder contains the demo script, which if we look at it, you'll see essentially first step we were going to build the filter, which was going to just like run make and yes, and then that would generate a rate limiting.wasm file, right, for us to copy into that wasm folder. Then the next thing we was going to do would be to simply do like there in line 43 and onwards a Docker run to launch the container. The new things in here is that, well, we're going to see there that in line 49, I'm specifying a demo.yaml config file, which will contain the configuration for our service route and our filter chain. And on lines 53 and 54, we enable Wasm, and then we set the filter path for that Wasm file that was copied earlier in the demo, right? So yeah, so if we go back up, yeah, if we go back up to the test folder, right? Yeah, let's look at the config there and see how that looks like. So yeah, so this is the typical configuration, like a very simple declarative config with one service, one route. The route defines path on the route, and then we have the filter chain with a list of filters with one filter, that rate limiting filter, which we would have just compiled, and the config, which is this string containing another JSON, right? Which is because we have implemented our rate limiting configuration to read a JSON, right? If you go up all the way up to the root of the repository, we were going to see that, yeah, if we go back up to the top level, we would see that, yeah, and if we go to, yeah, and if we look like at config in there, like that's where the config for the filter is implemented in like config.go, right? So that defines a config struct with like all of the fields that would be Json schema, like that would be read via JSON, right? And then like we run the ffjson generator, so I can generate like a JSON marshaller and a marshaller for reading that configuration, right? So I said I was going to give you guys yeah, so what happens with this filter essentially is that like with that configuration we looked at, like the demo script like issues 4 calls, like HTTP calls in the end of test.sh, and like the first 3 would pass and the 4th one would get rate limited, right? So I said I was going to give you guys a little surprise. So the surprise I'm going to give us that in the spirit of GitHub and collaboration, I am now from my machine, since I don't have screen share, I have just pushed a new commit to this repo. So if you go up and now you refresh, browser, So yeah, so now we have like, look at that. Like on the top, we have just a new commit that says feature add JSON schema metadata for Kong gateway. So this is new in Kong 3.5. Now you can do that. If you look at that. Now, if we go back to our test script, there is one tiny difference to it, which is if we scroll down here, copy wasn't like at lines 30 something. Go up a little, please, Vina. Yeah. If you go there, like now, instead of just copying line 27, instead of just copying the Wasm files, we also now copy a .meta.json file as well, which gives us a JSON schema configuration to match that Wasm file. So Kong Gateway now is able to verify that your configuration is valid, like prior to running, instead of failing at runtime, like Wasm filters, proxy Wasm filters normally do on Kong Gateway 3.5. It will verify the configuration ahead of time using this JSON schema configuration. And yeah, and not only that, now since we know about the shape of the configuration, if you enter the config folder now, so we can look at our YAML file, like this looks like a very simple change, but it's a major quality of life change. It's no longer a string, it's an actual JSON object in there. And like everyone who has played with Kong Gateway 3.5, that was like a unanimous piece of feedback that like everyone, the first time they tried to use like admin API calls and pass in the config, because it had to be like double escaped because you're doing an HTTP like admin API call to configure your filter chains and all of that. Like everyone had trouble dealing with like YAML with nested JSONs and all that. Because the thing is that proxy Wasm does not define on its own a config format. Like proxy Wasm itself, the standard, it only says the config is a string, right? So what we're doing here at Kong is that we're saying like, okay, if you want to use JSON objects, right? Like we will still support strings. If you don't, like it works the same. Like if you don't specify your meta JSON file, you will still be able to pass a string here, and your filters, like your third-party filters developed for Envoy or whatnot, everything will still work as normal. But if you add the meta.json file, you can now just specify like as if you were doing like Lua plugin configuration here, right? Except that this is verified ahead of time by the gateway using JSON schema. And now if we go up all the way to the top level, right, we will see that in this latest commit, we have a new file there, rate limiting.meta.json, right? And this is like bog standard JSON schema definition for a JSON object, right? You can set like what are the valid strings for an enum. You can say what is the regex pattern for the header name. Like you can specify what are the default values, like all things that like JSON schema allows you to do, right? This is essentially supported, and you just like give it a metadata file, you put in a field config schema, and you put a JSON schema inside, you know, and Kong Gateway will like start load this file alongside your Wasm file and give you that verification. And on Zoom chat, I'm also going to share here on Zoom chat, like, or if you just go there, instead of saying go rate limiting in the URL and change that to like AssemblyScript rate limiting, like that is also like, we also ported this go, we have also like, this one doesn't have the meta JSON file, but it works all the same, right? I could just copy that JSON file for that JSON schema, put in this repo and use it the same way, right? But yeah, I don't know. Yeah, like the script looks the same, because like that's like, it looks pretty much the same. Like that's the beauty of dealing with Wasm, right? Like once you have the binary, and this like is for this one, it is built with I think this still has the 3.4 configuration style. But yeah, but the interesting thing is like, even if you go there and compare like the source code, like this one still has a 3.4 style, which is still supported. But now like this one essentially implements that same filter using AssemblyScript. AssemblyScript, for those not familiar with it, is a dialect of TypeScript. It had like some small changes, but essentially, if you know TypeScript, if you know JavaScript, you can code in AssemblyScript, and that's an implementation of like those like ECMAScript family of languages, right? For the Wasm environment, right? So On 3.4, we have verified and we have tested and we have like essentially gone through like a verification step to say that we have tested the SDKs for Rust and Go, and we verify that they work. We also have like a Rust rate limiting, like this is our like go-to like like first test that we run to like for a more realistic filter. And this for 3.5, we have done the same work for AssemblyScript. We have integrated it in our CI and test suite and all of that. So now AssemblyScript is now also one of the officially supported languages from our side, right? And yeah, like given the constraints that I wasn't able to do the live demo and actually get it running, yeah, I think this was an interesting way to show you folks what are the differences. And yeah, and thank you so much, Veena, for driving it. Yeah, that's all that I had for Wasm and 3.5 for now, and now I think we're open to questions, and looks like there's a few already in there.
Yep, let's go to the Q&A part. Thank you so much, Hisham, Veena. You guys were awesome. Let's see the questions now.
Yeah, the Kong request ID, there's a question about Kong request ID and trace ID. So the request ID gets injected into, within the trace as well. So different spans within the trace, so you can correlate all of them together and back to the logs. With the correlation ID, what it was it was a plugin, so it was not out of the box. So now this request ID is something that you get out of the box. And if you don't want it, I think you can turn it off. But yeah, it's there. And recently we launched cloud gateways as well, wherein we are hosting the gateways. So we needed it for for managing our own infrastructure as well. So this kind of helps. This has been an ask as well from customers. So this with this request ID, you'll be able to, it gets injected into those spans as well for you to correlate. Is there a plan for 2.0 demonstrating proof of possession? Yes, so that is the next approach. So we did the MTLS one. For this proof of possession tokens, there are two methods, right? So basically it's tying to the cryptographic keys that have been shared, or it can be something that's generated on the fly. Two methods, and this deep hop is something that's still in draft. So that's why we opted to go for the MTLS first, because it's already approved and is in, a lot of IDPs already support it. Deep hop would be next based on our feedback from customers. They have asked for this, but it's the spec itself is in a draft stage. So we're waiting to see, get that finalized. The dev portal was deprecated in 3.5. What should be the alternative? I am not the authority to answer this, but yes, I think the there is backward compatibility. So I think if you already have a portal, it should continue to be supported. But in 3.5, you cannot create one. And I think we'll get answers for that one, Dahlia. So from our Connect team as well. I'm not so sure on that ask actually. Some breaking changes. Clusters, a single control plane, multiple. So have key ring enabled, hence some. We would have to take this one offline as well. So there shouldn't be, the breaking changes is the 3.4 is an LTS version. So there is some changes, breaking changes in that. I wasn't aware 3.5 had any. So I would have to take this one offline as well and get you the right answer from talking to by looking at it. But yeah, Talia, is there a way for us to capture these questions?
So I was going to say, for everyone who wants to take those questions offline, just join us on our community Slack. I will put the we'll put the link in the chat. So please join there, and you can find Veena, Hisham, and the rest of engineers, product managers from Kong, and you can talk to us there. I will add the link now.
Yeah, some of these connect questions, we'll have to bring in some of the connect folks to answer it correctly. I think the next one is for you, Hisham. How to enable filter chains for composite APIs or aggregators? Maybe another connect one.
Yes. So as of now, WebAssembly is in beta, and we have support for associating filter chains to routes and services, either via the main API or via the gateways declarative config file. So that which works for the DBless mode, for hybrid mode, and by essentially directly configuring the gateways. The work for like supporting the rest of the whole Kong ecosystem as a whole is in progress. So that will be coming, like support for doing it with via deck, via kick, and so on and so forth, and finally, of course, connect as well. So this is all of the like support for this entity, like throughout the Kong ecosystem as a whole, will be coming. And right now it's only implemented, like it's only shipped like for the gateway itself. I think the next questions are also the next two questions are also Wasm, so I'm just going to go ahead and read them here. So yeah, for first question, like, can we bake in the Wasm files to custom Kong images? Also, what will be the use cases that Wasm filters can be developed for in an enterprise? Okay, so two questions. Let's go one by one. Can we bake in the Wasm files to custom Kong images? Yes. So if you look at that demo.sh file that Veena shared, which is available in our example filters, that essentially works by mounting some local folders in there, because essentially what the configuration wants is a path, so that the filters are found in the local file system where the gateway is running, right? So if you build a custom image and you add that folder to your image, essentially then like your Wasm filters are ready to go, right? You just need to set your Kong configuration to point to that folder within your container, and that's it, right? There's no additional installation process, right? This is also different from, let's say, custom plugins where you have to do like Lurox install, and there are like a number of files that go into a number of folders. Like this is just like, if you have that one folder like available, accessible in your container, either mounted as a volume, like either like bundle in your custom image, and you configure that in the Wasm filter path, like Kong will be able to find it, like, and that can contain .wasm files and .meta.json files. The second part of the question was also about use cases, and right now, because of the proxy Wasm sandbox, the best use cases are data transformation, because there are several things that you cannot do, that you are able to do, like in Lua filters, in Lua plugins, and like Go PDK plugins and things like that, that you're not able to do in WebAssembly because of the sandbox. For example, you cannot like open arbitrary sockets or read arbitrary files from the file system, because that will break the sandbox, right? This is like a sandbox model that was originally designed for web browsers, right? So one tab cannot peek into the other tab, like in whatever you're running. So in that sandbox model, like the only features that are available are the ones that we expose. So what's exposed now is like the implementation, like the default WASI support for like basic system features like get clock time, such things like that, and the proxy Wasm APIs. And the proxy Wasm API gives you full control over the request lifecycle in terms of headers, callbacks, and like reading the body and all such things. Right. So I would say like the go-to use cases right now for proxy Wasm and Wasm filters, like especially as those standards get more robust right now, is essentially like data transformation. Next question says here that like the proxy Wasm Go rate limiting filter looks great. Thanks. And earlier a data store was needed in order to use rate limiting in a cluster. Is this still the case? Yes, this is still the case, because essentially like the Lua implementation of the rate limiting filter has two main modes, right? Like one, which is the local policy mode, and the cluster mode. So this one, because it is a proof of concept just to show someone how does the code base for a filter looks like, and allow you to compare, like, this is what the TypeScript code looks like versus the Go code and all that, to see like similarities and all that. So this only implements the local policy, which is essentially, but that means that if you have a cluster like you can do that in Lua plugins today without having like a Redis installed. But that means that, like, if you have a cluster of like with like 5 Kong nodes in your data plane, they all manage their counters independently, right? So if you put like 5 hits on each and you have a load balancer in front, like essentially you get like 25 hits, right? And by the random distribution of the load balancer, that's approximately what you're gonna get, right? So this is what the rate limiting there implements. It stores the counters in the Kong shared memory, like the same. Yeah. So the next question, yeah, that next one is not Wasm. So will you take that one video?
Yeah. So again, I would have to get back on what we're sharing regarding the analytics, because of some of the removed features like vitals and portal. This was before my joining Kong, so I am not very familiar with what capabilities they provided, but I know we do have some plans to support existing users. So I will get back on that as well, Dahlia. So if you can please note that.
Yeah, just please go to kongcommunity.slack.com. There is a Kong Gateway channel. If you put, Rodrigo, if you put that question there, you will get an answer. We have other engineers and product managers, so they will get that question. Thanks, Vina.
Next one is Wasm again, Hisham.
Yeah, is CRAC correct? Like coordinated restore at checkpoint available for Wasm, and what is the achieved full code speed? I don't know if those two questions are related, but yeah. So I'll be fully honest, like I wasn't familiar with the coordinated restore at checkpoint acronym, but I just looked it up, and it's essentially what it is a open JDK feature that provides a fast start and immediate performance for a Java application. Essentially, you build a snapshot, and like a memory snapshot of a started Java application, so that allows you to restore that snapshot in memory and have your applications start instantly, instead of like having to load the modules, imports, link everything, and warm it up. Wasm does not have that, and essentially the way the way startup works in Kong Gateway is that we start up at boot time, like start time, we load up the Wasm instances, and then we read the configuration, we load all the Wasm modules, and that happens on each worker, right? So each worker gets their instances, and you have different isolation modes for like further sandboxing or not, in which you may, if you want, you can, like if you want to go like full paranoid, like you can enable at a high cost of performance, you would get like a new instance on each request, right? So that it's a new memory image for each one of them. But the default mode, which is like the not isolated mode, what happens is that you get one instance, and that Wasm instance is long-lived, right? So you don't need to checkpoint and go back and forth like that, like what's described in Crack there, because the same Wasm instance keeps running with the filter called load at once, right? So, and for that, in terms of and that's no different from what already happens for Lua plugins. That's why we felt that this was like a safe default to go to. If anything, due to the sandbox nature, like the Wasm filters, even if they are long-lived, they are already restricted. I was just skimming through it, and the Crack implementations are used in things like Lambdas and things like that. So in a multi-tenant environment where you want to be running those short-lived things and restoring checkpoints, that does make a lot of sense. But in an environment where you control what are the filters that you're going to load, then it's simply fast, and you trust their code, then it's just simply faster to load them once and keep them running. So that's what we do at Kong gateway with Wasm. Hope that answers the question. And yeah, and I think we cover them all.
Yeah. Whoop, one more.
How is TTL defined for sender constrained access tokens, and is there an option for global invalidation of those tokens? So the token itself, the token, everything regarding the token management is on your IDP, right? So we check, when Kong checks, it's checking for a few things, whether it's valid, whether it has expired, things like that. So you would do the configuration on the IDP. Second one, is there options for global invalidation of those tokens? With it's an offline. Again, I don't know. I have to find out if there's some kind of revocation list that we maintain where we can revoke these tokens. But these are more like yeah, I'll have to find that out. I don't know if there is an option in Kong. I've seen that in some plugins we do have a revocation, but maybe that's not related to this. So if a token got revoked, this is the side effect of these bearer tokens, right? So there's no really as it's valid as long as it's not expired. But with sender constraint, let's say the token is out there, but your client certificate, we could check the client certificate if it has been revoked. So there are a couple of different ways we can approach that, but we'd have to explore that that option there.
All right. Any last questions before we wrap up? No. Let's give it a couple more seconds. I will put the link to our YouTube channel where you can find this recording in a couple of hours.
Yeah, so one last comment regarding Wasm. Like we will want to hear all your feedback regarding this feature and all these things that we're developing for it. Like it's super important to get like the feedback, like just like, for example, like the thing about like improving the configuration style was like the main piece of feedback for 3.4 to 3.5, and that's the one things that we prioritized. So we really want to get your feedback, and I would especially like to recommend like everyone who will play with it, like since it's a beta feature and we're working hard on it like all the time, to give it a try with the nightly containers. If you look at our demo scripts there in the go rate limiting plugin, like it already points to like Kong/Kong : nightly, right? Like for playing with the beta features, it's like it's a lot better to just play directly with the nightly containers rather than just go with like the version released like a month and a half ago or something like that, which because the nightlies might already have the features that you're looking for. So that was my last comment regarding Wasm. And yeah, and thank you all once again for sticking around.
Yeah, thank you, and appreciate the engagement and questions. If you have any particular requirements that you need to satisfy, please do reach out on the community Slack, and we can look at ways to satisfy that as well.
Cool. Thank you so much, Veena, Hisham. You guys were awesome as always. Thanks everyone who attended, and happy holidays. We'll see you next year for our other user calls. Bye.